That machine is the Large Hadron Collider. It's the world's biggest and most powerful particle accelerator, a multi-billion-dollar instrument. One of the Google searches that'll come out asks whether it can destroy the world.
A few years ago, the European Organization for Nuclear Research, CERN, decided to close its doors. This time, their decision seems to be influenced by some significant challenges they are encountering. They are shutting down to try to lessen these issues. However, a CERN official gave serious warning after it shut down about our universe and the forces that keep it intact. What exactly is CERN saying, and what should we anticipate from this sudden stoppage and serious warning? Join us as we unravel the mystery behind CERN giving serious warning after shutting down. The Large Hadron Collider. The Large Hadron Collider, LHC, might seem like something from a sci-fi movie, and in a way, it is. This machine is like a colossal racetrack, but instead of racing cars, it crashes tiny particles together at almost the speed of light. It's pretty amazing when you think about it. Imagine the LHC as a kind of time machine that lets us glimpse what the universe might have looked like just after the Big Bang. The LHC is a stunning piece of engineering, a massive ring that's 17 miles around and buried about 175 meters underground. It's not just in one country, but stretches across the border between France and Switzerland, showing how countries can work together to advance science. The whole project was very expensive, costing around $4.5 billion to build, with even more spent on maintenance and upgrades. But the results have been well worth it, helping us uncover the universe's most basic secrets. So, how does this incredible machine work? It's all about speed. The LHC whips tiny particles around its track so fast that they're nearly moving at the speed of light, completing thousands of laps each second. To reach such astonishing speeds, the LHC uses incredibly powerful electromagnets that create a magnetic field thousands of times stronger than Earth's. Some people were understandably worried about how a strong magnetic field might affect nearby electronics and even the Earth's magnetic balance, but that's just part of the setup. Once these particles reach their top speed, nearly 1 million times faster than sound, they smash into each other head-on. This is exactly what the Large Hadron Collider is made to do. Scientists are very interested in these crashes because they help us learn more about the basic building blocks of our universe. The crashes are intense, releasing a huge burst of energy and creating a bunch of different tiny particles. These new particles scatter everywhere, but they're short-lived, like fireworks that light up for a moment and then disappear. Most of them vanish almost immediately. Interestingly, by changing the types of particles that collide, scientists might discover new particles hidden within the chaos of the crash. To capture these brief and strange moments, they've built extremely sensitive detectors around the collision points. Think of these detectors as supercharged cameras that record every detail of the crash. However, all this activity creates a huge amount of data, over 15 petabytes each year. That's like having a whole library of information dumped on you every single year. Sorting through all this data is a huge task, but within this mountain of information lies the potential to uncover some of the universe's greatest mysteries. The Large Hadron Collider has done something truly amazing. It's challenged our current grasp of the universe and shaken up the world of physics. Scientists use a fantastic guide called the Standard Model, which is like a detailed instruction manual for everything in the cosmos. This model explains how all the tiny particles, like quarks and electrons, interact with one another, almost like following steps to build a complex Lego set. The Standard Model is pretty impressive. It describes everything from the smallest particles to the forces that keep them together. For example, quarks, which come in 6 different types with unique traits such as electric charge and mass, are fundamental building blocks. Then there are leptons, like electrons, which are crucial for forming atoms. And don't forget bosons, which are like the busy bees of the particle world, carrying forces like electromagnetism and helping to hold quarks together. However, even though the Standard Model is brilliant, it's not complete. It leaves some major questions unanswered. That's where the LHC steps in. By simulating intense collisions similar to those of the Big Bang, the LHC is uncovering new mysteries that our current knowledge can't yet explain. Take a look at the world of particles, using the beauty quark as an example. Recent findings from the Large Hadron Collider are shaking up our view of the universe in surprising ways. Scientists have discovered something unexpected. When beauty quarks decay, they don't follow the patterns we anticipated based on the standard model of particle physics. According to predictions, these quarks should transform into muons and electrons at similar rates. But what the LHC experiments showed was quite different, hinting that there might be new, unknown particles or forces influencing these processes. On top of that, the LHC is turning up some very strange particles that the standard model can't explain. One of these is the pentaquark, a unique particle made of 5 quarks instead of the usual 3 found in protons and neutrons. The discovery of the pentaquark is a big deal because it opens up possibilities for discovering new types of quark combinations we didn't know existed before. This could mean new, mysterious forces at the subatomic level that we're just starting to understand. The pentaquark's discovery was particularly impressive, showing a deviation of 15 sigma in statistical terms, far beyond the 5 sigma needed to confirm a particle's existence. This shows how precise and powerful the LHC's measurements are. But the surprises don't end there. The LHC also found another exotic particle called the tetraquark. This particle, named TCC+, is made of 4 quarks, 2 charm quarks and 2 lighter ones, all held together by a strong nuclear force. Just like the pentaquark, the discovery of the tetraquark suggests more quark combinations are waiting to be discovered. The TCC+ could also help us understand more about quantum chromodynamics, QCD, which is the theory that describes how quarks interact with each other. These are the basic rules that describe how quarks interact under extreme conditions, and they are a key part of the standard model of particle physics. This model is like a huge, complicated puzzle, but learning more about quantum chromodynamics, which is the study of these interactions, could lead to amazing discoveries about the fundamental nature of matter itself. The Large Hadron Collider played a crucial role in discovering something called the tetraquark. Scientists managed to spot a brief signal of this tetraquark, known as TCC+, during the chaotic proton collisions. However, the TCC+ is very short-lived, like a quick flash of light that quickly changes into other particles. The discovery of the Higgs boson. In an unexpected twist, the LHC also found that the Higgs boson, a vital part of our understanding of the universe, is heavier than we initially thought. But what exactly is the Higgs boson? Often called the God particle, it's a fundamental component of the Standard Model. It appears when the Higgs field, a key element of particle physics theory, gets excited through a process known as quantum excitation. In this model, the Higgs boson is the heaviest particle and is classified as a scalar boson, which means it doesn't spin. It has positive intrinsic parity, but no electric or color charge. Despite its importance, it doesn't stick around for long and quickly decays into other particles almost as soon as it is formed. Now, let's dive deeper into the Higgs field. Imagine it as an invisible field that fills the entire universe, influencing how particles interact and gain mass. This field has a special quality. It always has a value greater than 0, even in the emptiness of space. This feature, known as the Higgs mechanism, is what gives particles their mass. Imagine it as a cosmic party where the Higgs field invites all particles to join. At this party, particles get their mass, and in the process, a fundamental symmetry of the universe is broken. This remarkable idea was introduced by physicist Peter Higgs and his team in 1964. Their theory not only explained how particles gain mass, but also predicted the existence of the Higgs boson. Think of it like solving a challenging puzzle. If their theory was correct, a particle with certain properties must exist. And sure enough, the Higgs boson was discovered, proving their predictions right. Often called the God particle, the Higgs boson was finally found in 2012 after a 40-year search. Scientists at CERN in Switzerland, using powerful detectors called ATLAS and CMS at the Large Hadron Collider detected this elusive particle. The Higgs boson matched the predicted properties exactly, making it a crucial discovery. This breakthrough was so important that it led to the Nobel Prize in Physics being awarded in 2013 to Peter Higgs and François Englert, two of the key figures behind the Higgs mechanism theory. It's important to recognize how teamwork played a big role in this achievement. Between 1960 and 1972, many researchers, working on their own, each contributed important parts to what would later be known as the Higgs mechanism. Their efforts laid the foundation for our current understanding of the Higgs boson. Jump to today, and with the Large Hadron Collider gathering more data, scientists made a surprising discovery. The Higgs boson's mass was found to be greater than 125 giga-electron volts, GeV. This new finding shocked the scientific community. A heavier Higgs boson than expected might mean we need to rethink our fundamental understanding of the universe. It doesn't necessarily mean we have to discard the standard model of particle physics, but it does suggest that there could be new particles or forces we haven't yet discovered.
As a sculptor, how do I lose my determinism to shape particular bits of matter?
Imagine finding a new piece to a complex puzzle that could change how we see the universe. This heavier Higgs boson has sparked renewed interest in studying the Higgs field and its role in shaping everything we know. Scientists are still fascinated by the mysteries of the Higgs boson, and ongoing research promises to reveal more astonishing details about the universe's fundamental nature. The journey to understand the Higgs boson is far from over, and it will likely influence the future of particle physics. In 2020, scientists at CERN achieved a groundbreaking milestone. They managed to split the Higgs boson for the first time. This was a huge accomplishment, similar to decoding the universe's genetic code. But this discovery also raised new questions. The behavior of the Higgs boson didn't quite fit with the established rules of particle physics, hinting at the presence of new particles and forces we haven't yet grasped. Despite these monumental discoveries, the LHC still hasn't fully solved the mysteries of dark matter and dark energy. These two mysterious substances make up about 95% of the universe, yet their true nature remains largely unknown. Everything we know about stars, planets, and galaxies represents only a small fraction of the universe's total composition. The Large Hadron Collider is leading the way in uncovering the mysteries of dark matter and dark energy. By pushing the limits of what we know, it aims to reveal the secrets of these mysterious substances. But the LHC is not just about exploring the universe. Its breakthroughs have real-world impacts, too. For example, the technology behind the LHC has significantly affected our everyday lives. The World Wide Web, which we now use all the time, was first created at CERN to help scientists work together more effectively. Similarly, the advanced imaging techniques used in medical scans, like PET scans, were originally developed from particle physics research. The drive for fundamental knowledge often leads to surprising technological innovations that benefit society in unexpected ways. In short, the LHC is a remarkable example of human creativity and curiosity. It has already transformed our understanding of the universe and keeps expanding the boundaries of scientific knowledge. Although it raises new questions and challenges, the LHC represents our unwavering quest to explore and understand the cosmos. Each discovery brings us closer to grasping the essence of reality and our place in the universe. Unveiling hidden dimensions and quantum entanglement. The Large Hadron Collider, LHC, has been crucial in advancing our understanding of extra dimensions, offering a peek into realms beyond our usual three-dimensional world. Our vast universe might be just a tiny part of a much larger reality. The theory of extra dimensions suggests that beyond the length, width, and height we experience daily, there could be additional hidden layers waiting to be discovered. These dimensions might be curled up so tightly or be so tiny that our current technology can't detect them. Imagine looking at a thread from far away. It seems to be just a line, but up close you can see its depth and width. Similarly, these extra dimensions might be all around us, unnoticed because of their small size. Scientists are particularly interested in these extra dimensions because they offer a potential solution to one of the biggest challenges in physics: unifying the fundamental forces of nature. The standard model of particle physics successfully describes 3 of the 4 fundamental forces: electromagnetism and the strong and weak nuclear forces. However, gravity remains separate and significantly weaker than these forces. Integrating gravity into the standard model has been a persistent problem. Here's where the idea of extra dimensions becomes intriguing. According to the theory, gravity might be weaker because it spreads out into these hidden dimensions, which helps explain why it seems so much less powerful compared to the other forces. The LHC is essential in exploring this theory by probing the smallest particles and their interactions. Its history of revealing unexpected results from particle collisions makes it a key tool in this quest for understanding. Quarks act in a strange way that suggests there might be things beyond our usual understanding. These unusual behaviors hint that our current knowledge might be missing something important, like the possibility of extra dimensions. This idea connects with exciting theories like string theory. In string theory, particles aren't just tiny points, but are instead tiny, vibrating strings that exist in multiple dimensions. For this theory to work, there need to be at least 10 dimensions, so these strings can vibrate and create the particles and forces we see. The key is its ability to speed up particles to incredibly high energies. When these particles smash into each other at such high speeds, they break apart into their fundamental pieces, revealing the forces and interactions at play. Scientists carefully study these collisions and the patterns in which particles decay to look for any hints of extra dimensions. Imagine a powerful collision, creating a burst of subatomic particles. Using the known particles involved, scientists can calculate the total energy and momentum before the collision. If extra dimensions are real, some of this energy and momentum might seep into these hidden realms. Detecting any mismatch between the expected and observed energy and momentum is crucial. Even the tiniest difference could suggest the presence of extra dimensions. It's a delicate task, like trying to hear whispers in a loud room. The detectors must be incredibly sensitive to catch these faint signals. Another method to find extra dimensions involves studying how particles decay. Normally, particles decay in predictable ways according to the standard model. However, if unknown extra dimensions affect these decays, the patterns might change. Scientists scrutinize these decay processes for any unusual patterns that could hint at extra dimensions. The search also extends to the intriguing idea of micro black holes. These tiny black holes, much smaller than the ones in space, might form during high-energy collisions in the LHC. Some researchers think that extra dimensions could be linked to the creation of these micro black holes. The idea is that gravity, which is weak in our familiar 3 dimensions, might be much stronger in these additional dimensions. Finding micro black holes could be a sign of extra dimensions. This exploration offers a fascinating way to understand the connection between gravity and extra dimensions. Quantum entanglement is one of the most intriguing mysteries in physics. It blurs the line between science fiction and reality. Imagine 2 particles connected in such a way that the state of one instantly affects the state of the other, no matter how far apart they are. Albert Einstein called this spooky action at a distance. This idea challenges our traditional view of how the universe works. What's puzzling about entanglement is that it seems to break well-known rules, especially Einstein's theory of relativity, which says nothing can move faster than the speed of light. With entangled particles, it appears they exchange information instantly, suggesting a form of communication that bypasses space and time. But even though entanglement seems paradoxical, it doesn't defy relativity. Instead, it gives us a peek into the strange world of quantum mechanics, where particles can be in multiple states at once and act in ways that defy our everyday understanding. CERN is at the forefront of exploring these mysteries. Their goal is to gain deeper insights into how the universe works by studying how quantum mechanics and relativity intersect. Scientists at CERN carefully conduct experiments with entangled particles, observing how they interact over different distances. The Large Hadron Collider at CERN, allows researchers to measure these particles with exceptional precision. Understanding quantum entanglement could revolutionize our view of the universe. If particles can be linked over great distances, could this connection also extend through time? Answering this could change our understanding of how time flows. Additionally, exploring entanglement might lead to the discovery of new dimensions. Certain properties of entangled particles suggest there might be dimensions beyond what we currently perceive. An entanglement could help reveal the structure of these hidden realms and how we might interact with them. Quantum entanglement is not just a theoretical idea, it has the potential to transform technology. For example, quantum computers could use entangled particles to perform calculations far beyond what traditional computers can achieve. This could lead to major advancements in fields like cryptography and drug discovery. Secure communication channels that are nearly impossible to hack are just one example of the exciting possibilities. CERN's research goes beyond black holes. They are also investigating wormholes, which are hypothetical shortcuts through space and time. By uncovering the secrets of quantum entanglement, CERN is pushing the limits of human knowledge and paving the way for groundbreaking discoveries in both physics and technology. Secrets of wormholes. Imagine taking a trip through a wormhole, a hypothetical shortcut that could let you zip across the universe. This exciting idea, along with the idea of parallel universes, is key to the research happening at CERN. Now, let's look at something called supersymmetry, or SUSY for short. Think of SUSY as an extension of our current understanding of physics. It suggests a mirror universe, where every particle has a twin with similar properties but different behaviors. For example, each force-carrying particle, called a boson, would have a partner that is a matter particle known as a fermion, and vice versa. This theory is very promising for solving the mystery of dark matter, the invisible substance that makes up a large part of the universe. SUSY particles might be the missing pieces of this cosmic puzzle. Their stability, mass, and interactions seem to fit well with what we know about dark matter. The Large Hadron Collider, LHC, is crucial in studying SUSY. By recreating conditions similar to those right after the Big Bang, the LHC lets scientists look into the very foundation of the universe. If SUSY particles exist, they might be produced in these high-energy collisions. Additionally, SUSY helps us understand extra dimensions, which are essential for string theory. This theory suggests that extra dimensions are needed for its equations to work. SUSY helps to stabilize these dimensions and might offer ways to observe their effects, perhaps through tiny changes in force strengths or particle masses, things the LHC could potentially detect. The LHC acts like a powerful microscope, allowing us to explore the hidden parts of the universe and separate fact from fiction. CERN, the European Organization for Nuclear Research, is at the forefront of this scientific adventure. However, its groundbreaking work with subatomic particles and fundamental laws has also attracted some outlandish conspiracy theories. One particularly worrying theory is that CERN might be trying to open a portal to hell. Some conspiracy theorists think that CERN's experiments, which involve smashing tiny particles together at incredibly high speeds, could accidentally lead humanity toward a dangerous, fiery realm. However, CERN insists that its mission is purely scientific, to better understand the building blocks of matter by studying antimatter. Antimatter, as its name implies, has electrical charges that are the opposite of normal matter. According to the Big Bang theory, antimatter is extremely rare and likely formed right after the universe began. Another conspiracy theory connects CERN to the Mandela effect, where many people remember events differently from how they happened. Some people speculate that CERN's particle experiments might be messing with the very fabric of reality, causing widespread Mandela effects. There are even wilder theories claiming that CERN is involved in human sacrifices, supposedly based on a leaked video showing ritualistic activities. CERN strongly denies these claims, calling them false. It's important to remember that despite these sensational theories, CERN's main goal is scientific research. Recently, CERN's Large Hadron Collider made a significant breakthrough by detecting elusive subatomic particles known as neutrinos. This discovery could offer valuable insights into how neutrinos interact with other particles in stars, potentially revealing more about cosmic events like supernova. Neutrinos, often called ghost particles because they are nearly invisible, are found everywhere in the universe. However, they are very hard to detect because they rarely interact with other matter. Since they were first discovered in 1956, scientists have been intrigued by these mysterious particles. Even though they are common across the cosmos, tracking their interactions is a real challenge. In 2021, physicists at CERN managed to spot the presence of 6 neutrinos, but it took them 2 years of careful research to confirm their findings. This demonstrates just how difficult and demanding studying neutrinos can be. James Boyd, a particle physicist at CERN and a spokesperson for the Phaser collaboration, points out that studying these elusive particles is crucial for exploring the vast mysteries of the universe. As research continues, the scientific community eagerly awaits CERN's next major discovery and its potential impact on our understanding of the universe. Now it's time for today's subscriber pick. Dr. Elena Martinez, a CERN physicist, sat back as the LHC's huge hum faded into silence. The collider had been shut down for regular maintenance, but today was different. As the last beam was turned off, Elena found something unexpected, an encrypted message hidden in the data streams. The message was a cryptic warning. The boundaries are weakening. The fabric of reality is at risk. As the sun rose over Geneva, Elena's curiosity turned to worry. She and her team decoded the message, revealing a chilling prediction. The particle collisions were unintentionally destabilizing dimensions beyond our own. The message warned that further experiments could tear at the seams of reality itself. Elena rushed to the director's office, her hands shaking. The official listened closely as she explained the danger. By evening, a CERN official gave a serious warning after it shut down. Further experiments postponed indefinitely. Safety measures are in place. The world watched in awe and fear as the hidden consequences of scientific exploration became all too real. The discovery not only paused experiments, but changed humanity's understanding of its place in the universe. What do you think the future holds for particle physics after this discovery? Let us know your answer in the comments section. CERN evolution. Tim Berners-Lee came up with the idea for the World Wide Web in 1989 at CERN. His goal was to help scientists across the globe share their data more easily. Before this, researchers had to print out lots of individual pieces of paper and keep track of them manually. What started as a tool for particle physics has grown into something much larger, including applications like PET scans, which are now commonly used to diagnose cancer and have saved countless lives. CERN has always been open about sharing knowledge and encourages others to do the same. CERN's director, Fabiola Gianotti, illustrated this idea by comparing it to the history of lighting. If people had only focused on making better candles, we might never have developed electric lighting, a breakthrough that transformed history. CERN's research shows how powerful discoveries can be when scientists push limits, work together, and share their findings. Despite its groundbreaking work, CERN has faced concerns and skepticism. Some people worry that the Large Hadron Collider, LHC, might create black holes or strange matter, which could pose dangers. For instance, there's fear about the LHC potentially making microscopic black holes that could shed light on the Big Bang, but might also seem threatening to those who don't understand the science. Another worry is a strange matter, a theoretical substance that could, in theory, spread and affect Earth's materials. However, there is no evidence that this has ever happened or that strange matter exists in nature. In addition to these fears, there are other concerns about cosmic ray radiation and high-energy particles. Nevertheless, CERN has strict safety measures in place, such as limiting experiment energy levels and regularly checking equipment. One of the most alarming fears that has circulated, especially on social media, is that CERN might be creating portals to other dimensions, potentially letting in demons or evil spirits. Despite the dramatic rumors, CERN's primary focus remains on advancing science and ensuring safety in their experiments. On July 5, 1998, people were buzzing with fear because the machine was rumored to be ready for activation. This concern was fueled by the alignment of planets on June 24th, which sparked widespread panic around the globe. A TikTok video circulating on Facebook features a woman claiming that CERN, a scientific research facility, is a demonic machine that opens portals to other dimensions, hell, and other spiritual worlds. According to her, this would let in demons, wicked spirits, and evil entities. The idea of portals to dark forces has been around for ages, but the anxiety caused by the pandemic and the spread of such theories on social media has only intensified these fears. It's crucial to check facts before believing such dramatic claims. Unverified rumors can lead to unnecessary panic and hysteria. While CERN does conduct experiments related to alternate dimensions, there is no evidence to suggest it's opening portals for demons or evil spirits. CERN is a research center focused on advancing scientific knowledge and collaborates with the global physics community. It's highly unlikely that such a prestigious organization would have malicious intentions. We need to remain skeptical and evaluate the truth of these claims before reacting. Believing in baseless theories can cause unnecessary distress worldwide. It's better to rely on facts and continue learning about the world rather than give in to fear and misinformation. For now, CERN isn't planning to open any harmful portals or let anything dangerous into our world. While it's true that CERN has made groundbreaking discoveries, it seems unlikely that they are currently working on opening dark portals. Still, keeping an open mind is important, but we should also focus on what is happening rather than on speculative fears. What are your thoughts on the astonishing findings of CERN and the stern warning from its official? Share your opinion with us in the comment section.